So is it recording?
Yeah.
Okay.
It's been recording this entire time.
Oh, hello. So it's me here in this building with a whiteboard. I'm going to show you the impossible question from ISU's physics department. This is sponsored. Not really, don't tell them. So we have a cannon, right? Some angle theta relative to its position on this ledge. All right, that's good. I'm going to switch colors now. So at approximately high noon on the planet it's on, it shoots out this convoluted mess of masses. They all have the same mass. We have a mass in the middle connected to a spring to four other masses of the same mass. This is not drawn to scale, by the way. I need to make mention of that. They all also are charged in some configuration like this.
Are they of equal charges?
They all have the same magnitude. Don't interrupt me, boy. So, as it's traveling across its, I don't know, flight path, I guess, at its very zenith of its flight, something magical happens. It breaks apart in two. So now we have two systems like this. That's not a spring. and they're still charged like that. Due to some unforeseen things like a airplane or a bunch of birds.
So it went from 3 vacuum, 5 body masses to 6. How'd you get that?
Went from 5 to 6. All right, so
Then the one split in half.
all right, so we have who's the guy from Overwatch that shoots really well?
What?
Who's the cowboy?
I don't know. Not Hawkeye.
McCree.
McCree. So we have McCree shoot this in half with a bullet because he's just that good.
A bullet of infinitesimal mass.
Yes, but it has velocity relativistic to the speed of light.
So it does impart some
But it
momentum
affects its
onto it.
momentum.
It affects its momentum. That's all you need to care about.
Are all the springs the same spring constant?
Yes. No. No, let's make them
Yes.
different. While all this is happening, we've set up a rocket, and some configuration is this. The radius of R. Use your imagination because the budget for this rocket is very little. That's why it's in a cylinder.
Is it hollow though?
Of course it's hollow. How do you think rockets work? All right, so the inside of this rocket, we have a magnetic field happening of just monopoles. Very difficult to make. Anyways, we've set it up so when this mess collides with this, it will go through this and exit out the other side. Maybe. We don't know yet. So let's go over to the rocket's engine propulsions. We have two that make nuclear fission reactions that power up some sort of convoluted electrodynamic system of circuits or whatever. The other two are fusions, and they do the same thing. This is the future, and this is in space, and we're all dead from that.
Plasma?
No. What it does is it bends space-time.
All right,
Propel it
so
forward.
once they go through,
You're forgetting the black hole in the
Creates a
horizon.
potential.
I'm getting to that point.
Creates
Once
a
they go
potential
through,
wave that pushes it.
they will be launched near the event horizon of a black hole. It's in purple because you can't see it anyways. With some Schwarzschild's radius of R prime, and we're gonna make that. And this mess is coming over here. The question is, what's the speed of it? Not any of this cannon as it gets fired from.
At what time?
At what time? And does it oscillate? The answer may surprise you. We don't know, nor do we care.
Answer in the Fourier transformation and graph it in 6 dimensions.
Exactly.
What are the 6 dimensions?
So we have.
6 spatial dimensions.
So we got the 3 important ones: X, Y, and Z.
Yes.
Then we have the 4th dimension, T, which is just a box within a box. So we're going to have to draw it. Again, not to scale. But then we have to, throw in some quantum physics components like Schrodinger's cat and
So we put Schrodinger's cat in that box.
yes, that's the fifth dimension. And that's to alleviate all possible outcomes of reality at the same time. But it only takes one of those.
Okay.
Then we have a bigger box.
Are we modeling?
And that box is all possible realities happening at the exact same
Are we
time.
modeling them as an exponential or factorial?
Both. Well, both for this.
So now what's part B of the question?
Part B is if this is rotating in a counterclockwise direction, when it
Wait,
gets
that's
shot out.
rotating.
I didn't say it was rotating in the first question, so why'd you assume it? Alright, so now it's rotating like this. Like they're in a
They're in a plane.
exactly. They're rotating in a plane. But that plane is rotating through another plane. So it's not only is it rotating this way, it's rotating that way. It's gonna be a mess. I want you to model this movement as a 3D animation, as a function of time.
But which language are we going to use to code this?
Okay, so we're gonna use something called JavaScript. And this is how it's spelled in pink.
You have 10 minutes.
Yeah, you got 10 minutes. I don't know what else you can do.
There's some partial credit.
I can show that it's rotating like this and like that. This is also rotating like that, but in the opposite direction.
So this rocket is spinning out of control.
And are we assuming the mass of the rocket changes as it propels itself?
Of course,
Well, yeah,
of course it does.
Obviously, it loses mass because it's spinning at these relativistic speeds.
And
the
I
way
want you
it-
to find its rotation based on its center of mass.
But in what frame?
All three frames. To itself, to this mass, convoluted mess, and to the rocket.
To the center of mass of that mess?
Yes, the center of mass, which is right there. And then to the black hole. Part C, and this is for extra credit. Imagine if someone is on said rocket as it ejects itself out of its planet's escape velocity and they're standing still. So now we have a normal force.
Wait, where was the normal force coming from? What's pushing it down for there to be a normal?
Obviously, gravity.
Obviously, this rocket is massive enough to have its own gravitational pull on this guy. But then we have this absurdly huge, it's not force drag, it's just propulsion.
So are we in a vacuum or not?
We're not in the vacuum yet, but
Wait, so which drags are we going to consider?
so we're going to consider both kinds. We're going to use big L and little q.
Does this one take into account cubic?
No,
Oh.
no, we're going to use to the fifth power drags.
Oh, so there's no cubic, but there is to the...
No, there is cubic. There's normal drag, cubic drag, and then
No fourth.
quintuple drag. No quad drag. That's dumb. I want this guy to jump off and try to land as close as he can to the middle of this black hole. How fast does he need to jump off? And why?
Why? Why would he do this?
Why?
And
What kind of philosophy would allow him to throw himself in there? The answer might surprise you. So there's this movie called Interstellar, made in 2014. And in it, there's this big convoluted circle time trap, and he's just stuck in it, right? How does he get out? Well, same way the movie does. Just jump into a black hole and, just throw away the consequences.
right, so we're going to the bookcase at the end of the universe.
Yes. No, we're going to the center of the universe.
How do you define the center of the universe if it's expanding equally in all directions
There
at
is
every
actually,
point?
everyone's wrong.
Exactly.
There is actually an absolute inertial reference frame.
Well, you said in the question, yourself, if this is the universe, there has to be something outside of it, and it's just expanding in every direction in the same way. So there's got to be a center. I feel like it's right there.
If you're at the edge of the universe, is it expanding the same?
I mean, once you get to the edge and you stay there, don't you just see it go past you? Figure it out.
Right. Do you want salt response essay?
20-page essay, it's only 60% of your grade, and you have to turn it in and get at least a 70% on it to even get the chance of failing. If you don't turn it in, I'm just not going to acknowledge your existence at all. And it's a waste of my time, it's a waste of your time. get to it. All right, you can cut it off from there.